Today's lesson is about how to multiply terms that have powers. Remember, powers and exponents means the same thing. First, I want you to simplify each expression using what you learned in 8.1. So remember that a to the power of 2 means you have two a's multiplied together. A to the power of 3 means you have three a's multiplied together. So when you write that out, and count how many a's you have, there's 5 a's. In other words, the answer is a to the power of 5. Pause the video and try the next one. You should get a to the power of 7. If you have 4 a's and then you have another 3 a's and they're all multiplied together, that's 7 a's multiplied together, a to the power of 7. For the third one, try it without writing out all the a's. Can you make a theory on what the answer is? You should get a to the power of 30. If you have 10 a's and then another 20, you may have realized there's a shortcut. That's 30 a's total. In other words, you just add the exponents, the powers, if the bases match. Go ahead and try numbers 1 through 6. Simplify each expression. Here's number 1. I want you to notice that when you have 4 to the power of 3 times 4 to the power of 5, and you add your powers, the base number 4 itself stays the same. You don't change it into a 4 times 4 equals 16, because 4 to the power of 8 really means you've got 8 4's multiplied in a row, not 16's multiplied in a row. So keep in mind that the base does not change. Try the next 5 problems all the way through number 6 and pause the video until you're done. Go ahead and check your answers. One thing I'd like to point out about these is that when you have a variable such as this y in problem number 4 that has no exponent, that really means it has an invisible power of 1. Because it's like saying I have 4 y's multiplied in a row and then I have one more y. So really, 4 plus 1, I've got 5 y's, y to the power of 5. So anytime you see a variable without a power, it really means it has an invisible power of 1. So I would write it in to make adding the powers easier. Sometimes, however, you have a more complicated problem. When you do, follow these 4 steps. First, see if there's any variables that have no exponent, and then write in the invisible power of 1 on those. Second, reorganize your expression so that like terms are multiplied next to each other. Third, multiply the coefficients, the numbers that are normal, not variables. And lastly, add the powers on pieces of your expression that have the same base. We'll work through an example together. So here we have 4y squared times 3y to the power of 11. When you reorganize so like terms are next to each other, the 4 times 3 coefficients would move to the front and the y's would move to the end. Now you can multiply the coefficients and get 12 and add the powers on the y's and get 13. Your final answer is 12y to the power of 13. For your very final answer, you tend to leave off the time signs to write it in the simplest form possible, just 12y to the power of 13. Because remember, if there's nothing between your 12 and your variable, it's presumed that it's an invisible time sign. Go ahead and try question 2 and pause the video till you're done. Question 2, make sure that you caught that this x at the end of the problem had invisible power of 1. So when you sorted out your like terms, it was really x2 times x1, x3 at the end of your expression, negative 15x3. Go ahead and try the next 2. Pause the video till you're done. For 3, check that you got x to the power of 9, y to the power of 8. Notice how it doesn't simplify further than that. Because x's and y's are different bases, you can't add those powers and say it's any one letter to the power of 17, because you're counting two different types of things. You're counting x's and y's. So x9, y8 is your very final answer. For number 4, notice this time how your coefficients, the 3/4 and the 12, one of them is a fraction. When that happens, I'd write my other coefficient as a fraction and multiply straight across. 36/4 simplifies to a whole number 9. Now, a couple things to point out. When you have a1 times b2, those are things with different bases. They're counting a's and counting b's. Since they're not counting the same type of thing, you cannot add the powers, so they stay separate in your final answer. In your final answer, it's typical to write it in the simplest format possible. In other words, leave off details like time signs when they can be written invisibly, and powers of 1, because seeing just 8 tells us that it's an invisible power of 1. Pause the video and try the rest of the problems on your own. For 5, I want you to make sure that you kept the base 5, that you did not multiply 5 times 5 and make it 25, because remember, the things you are counting here are all 5s. That doesn't change. So you just add the powers and get 5 to the power of 9. For number 6, make sure you write in the invisible power of 1 on that a, and then sorted it out so normal numbers were in front and a's were at the end. You should get 50a to the power of 5. For number 7, you should first write in the invisible powers of 1s on the m's and then sort it out. So you have your coefficients, then your m's, and then your n's. 1 times 6 is 6, 2 times 1 is 2, 6/2 gets you a solid whole number of 3. Add your powers on the m's and you get m squared. Now the n squared can't combine with anything else because there's no other n's in the problem, so this is your final answer. For number 8, when you sort it out, you're going to notice that in the textbook, it's typical to sort it out so it's in alphabetical order, x's, and then y's, and then z's. While not strictly required, it's a good idea to keep your answer organized and make it easier to check in the back of the book. You should get 18, x to the power of 9, y to the power of 12, z squared. Great job, everybody. Don't forget to turn in a picture of your notes on Schoology.